Hi, eighth graders. All right, so this is inequalities solving part 2. So the first part, I'm going to work through these problems with you. We'll fill in the table. We'll fill in some of the table together. We'll go over some of our findings here at number 3, and we'll solve a few problems together. But before we begin, there's sort of some introductory problems for us to work through here. So number 1 says circle the numbers -3 and 5 on the number line below. So here's -3 and here is +5. So it says which of these two numbers is smaller? Write your answer below and in your explanation refer to the number line. So up here, we circled -3 and 5. I'd love for you guys to go through and pause this video and write down your answer for part B right now. And once you've done that, we can move on to part C. It says insert the correct symbols. We have less than, greater than, less than or equal to, or greater than or equal to into the box. And I know that -3 is less than 5. I suppose we could also say that it's less than or equal to, but we know for sure that it's less than 5. So moving on to D, by multiplying the -3 and 5 by -1, fill in the boxes below and represent the answer on the number line in part A. So -3 times -1 is going to be +3. I'll come up here and put a box around that. And 5 times -1 is going to be -5. And I'll come over here and put a box around that. So which of the numbers from part D is smaller? And explain your answer referring to the number line. So it looks like our values sort of flip-flopped here. So before we had -3 is less than 5, and now I have -5 is less than +3. So I know that -5 is smaller. Another sort of side example that I would like to go over with you, actually, you know what, let's do that a little bit further down the line. So here it says fill in the table below. So my original inequality is 4 is greater than 1. And I want to multiply both sides of the inequality by -1. So I'll do this first one up here. So 4 is greater than 1. And I want to multiply this by -1, and I want to multiply this by -1. So I end up getting -4 is greater than -1. Is this true? Is -4 greater than -1? No, that is not true. My resulting equality when I multiply both sides by -1 is -4 and -1, and I know that -1 is larger than -4. -4 is smaller than -1. Looking here, this when I multiply both sides by -1, I end up getting -3 and -5, and to fill in an appropriate inequality symbol in between those two numbers would be that -3 is larger than -5. 6 is greater than -4. This would give me -6 if I multiply by -1 and +4. +4 is greater than -6. This is going to give me -5 and -4. And I know that -4, we can use the symbol that they used before, is less than or equal to instead of greater than or equal to. Here I can multiply by -2. So 10 and -4. I know that 10 is larger than or equal to -4. Multiplying by -3. I end up getting 3 and +18. And I know that +18 is larger than 3. Here I'll end up with 8 and 3. And I know that 8 is greater than or equal to 3. 7. So here I have -7 and -7. And these two numbers were the same to begin with. So we could fill in greater than or equal to, or less than or equal to also works. This ends up giving me -10 when I multiply both sides by -2 and -8. And I know that -8 is larger than -10. And I'll let you fill in the last 3. But what I'd really like for you to do is I'd like for you to notice the symbol here and the symbol here. The symbol here and the symbol here. My symbol here, my symbol here. I want you to take a look at what happens to the symbols when we multiply both sides by a negative number, and maybe sort of predict what's going to happen for the last 3 symbols. And it looks like we can conclude I started with a greater than, ended with a less than, started with a less than, ended with a greater than. It looks like we can conclude when multiplying an inequality by a negative number, switch the inequality symbol. So the number sentence holds true. So here, in order for my inequality to stay true when multiplying by a negative number, we need to switch the inequality in our final answer. So let's do an example here. Let's take a look at C. Ooh, that's not the highlighter. Let's take a look at C here. So I will subtract 3 from both sides, and I'll end up with -2x is less than 26. Here I'm dividing both sides by -2. So dividing both sides by -2 here, I am going to then call this x is greater than, so I'm flipping my sign because I'm multiplying or dividing by a negative number, is greater than -13. So on my number line here, I have 0 and -13, and let's call this 5. I will have an open circle here at -13, and all of my x values that are greater are in this direction. So let's do one more example. Let's look at example F down here. I can subtract 3 from both sides, so -3x is greater than or equal to 14. And I can divide both sides by -3. And when I do that, I'm going to switch my inequality here because I'm dividing by a negative number. So x is less than or equal to -14 divided by 3. So on my number line, if I have -14 over 3, I have 0 here. I am looking at I'll have a closed circle here, and I'm looking at all of the x values that are smaller than -14 over 3. So maybe we should come back up here and add when multiplying, and let's do this in another color, or dividing. So that will yield the same results. Multiplying or dividing an inequality by a negative number, you need to switch the inequality symbol so the number sentence holds true. And we have lots of examples up here about why that is the way that it is. So to sort of piggyback off of that division example, if I started with 4 is greater than 1, and I divided both sides by -1, I would end up with -4 and -1, and I know that I would still flip my symbol here. So there's some examples for you. I'd love for you to keep working on number 4 and come back up here, make sure that 1B and 1E are answered nicely. Good luck, guys.